For those of you who watched the last Tech Byte that I recorded, where I showed the prompt editor of Generative AI Hub in SAP AI Launchpad, you might wonder how you should implement a more sophisticated use case with Generative AI Hub. And the answer is there are a couple of ways that you can do that. You can either just use the standard REST calls from anywhere, ABAP, JavaScript, Python, wherever, where you just use the deployment URL that I showed you last time. And I'm also going to show you in a second here. Or you can use one of our SDKs. So there's the Python SDK, for example, that we will be looking at today. And there's a very new JavaScript SDK that you can also use to implement like just standard prompting use cases, or since our SDKs are compatible with LangChain, you can also use them to implement more sophisticated use cases like agent orchestration, retrieval augmented generation, which is a technique to ground models, or like your chat history management, and so on. So today I will show you how you can ground a large language model using the Python SDK of Generative AI Hub on SAP AI Core and LangChain, and also the HANA vector store, because what you need is context information to ground your large language model. And with retrieval augmented generation, what you basically do is you turn your context information into vectors, so into embeddings. And then when you receive a prompt, instead of just giving that prompt directly to your large language model to respond to with its knowledge base, what you do is that you first find the relevant context information in your vector store, so that the large language model can use this relevant context information from the vector store to respond. And how that works is that you turn your prompt also into an embedding, and then you just compare the embedding vectors, and then you find the vectors that are most relevant, so that are closest in this vector space to your original embedding, to your prompt embedding, and then you feed that the text of that vector as context information. And one example to maybe understand how that works exactly is when I went to school, or when you went to school, and you had to read a book, and then you had to write an essay about the book, or an exam, or whatever. Honestly, I never read the book. So in my generation, what we did was we bought these really small summary books. In Germany, they used to be like these really small yellow books that were very short. And if you read those, you could kind of like sneak through every exam, you know, and the teacher might notice, I don't know, but you could just answer enough questions to get through. So that's what I did. And your child nowadays might have the smart idea of using GPT to respond to those questions and write the essays about the books and everything. But the problem is your child cannot validate the response of the large language model because your child didn't read the book, right? Now, I'm assuming that the teacher read the book, so the teacher might notice if the main character all of a sudden has a different name or the storyline is kind of off. So what you can do is implement a retrieval augmented generation use case. So basically you store all the books that your child has to read in a vector database. And if it's a small use case and you just want to try it out, you don't need HANA vector store. You can also use like a local small vector engine. I can also show you that in a bit. And then you store all these books in a vector database. So basically you turn the books into smaller text chunks. And then these text chunks you turn into embeddings. And those embeddings you store in the vector database. And I'm going to show everything step by step in a second. And now when your child has to write an essay or answer a question, you prompt the large language model, you turn the prompt into an embedding as well, and then you compare the embedding of the prompt to all the embeddings of the books in the vector store, and then you find the relevant information. And that way you can make sure that the model does not hallucinate, which is basically like lie, even if it hasn't read the book, or even if the book wasn't part of the training data of the model. Yes, so that's what we're going to do today, using Python SDK, LangChain, and HANA vector store. Let's get started. So here you can see all my deployments that I have in AI Launchpad, that I have on AI Core, and this is my AI Launchpad. You can also use this to deploy more models if there's a model here that a different model that you want to use. Today we will be using the embeddings model and GPT 3.5. Now, why do we need embeddings? Embeddings are basically just a number representation of words. And since machine learning models always need numbers and not words, we have to turn words, sentences, documents into embeddings so that a large language model can work with them, can understand them. And in the case of, for example, OpenAI, an embedding has a vector with 1,536 positions, so basically a lot of numbers. And I can show you one of those vectors in a second. Yeah, but as I said, you can also just use the deployment URL to work with Generative AI Hub, but we will not do that today. Otherwise, you could just copy this URL here and then use your bearer token and go ahead. But we want to use the Python SDK because that enables us to implement more sophisticated use cases, as I already said. Okay, so the Python SDK of Generative AI Hub is called Generative AI Hub SDK. And you can just install it using this command, pip install Generative AI Hub SDK. You also have a couple of examples here. And first you have to configure your AI core credentials, but you basically just store that in a config file. Yeah, the file has to look like this, and you need all the information from your AI core instance, and you get that from here. When you go to your BTP cockpit, you have your AI core instance, and here you have the service binding, and then you have all the information here that you need, and you can just copy that into how this file has to be formatted and store that at the root like this and call it config.json. Very simple. Okay, and then there are some examples here that you can also look through if you want to. And yeah, here you see the embedding model, chat model, completion model. The difference between a chat and completion model is basically that a large language model by itself does not chat. It cannot have like human-like conversations, but it basically completes things. So if you, for example, would ask a completion model a question, it would probably just give you very similar questions because it would just complete whatever you're doing. But the chat model was actually fine-tuned using reinforcement learning techniques and supervised learning techniques, actually the other way around, supervised learning techniques and then reinforcement learning techniques to make it have like conversations, to make it understand that when you ask a question, you actually want a response. Yeah, so that's the chat models. Okay, so let's go to our Python IDE. I'm using Visual Studio Code, and hold on, let's clear this so you're not confused. I always create a virtual environment because when you install packages in Python, you don't want to mess up all your other environments, and then you don't install the package for everything. So I created a virtual environment. I installed my package with a pip install Generative AI Hub SDK command, and then we can already start. And since I deployed my models, you have to make sure your models are deployed, otherwise you obviously can't query the models. But my models are deployed, we already checked that in the Deployments tab in AI Launchpad. And now we can, for example, create an embedding for the word dog. And as I said, the embedding is just a lot of words, which we see in a second. Yeah, so there are a lot of words here, a lot of numbers here for that one word. And now if you would, for example, create the embedding cat, you would see that those vectors are very close together. But if you, for example, would create the embedding Paris and dog would be a little bit further away from each other. But what you can also do with these vectors is because they hold this, like all this context information and a lot of meaning, you can also do like vector calculations. So for example, you could use the vector Paris and the vector France, and then you could subtract the vector France, the vector Paris from France, and then add the vector Germany. And what you would get is actually the vector of Berlin, because Berlin is to Germany like Paris is to France. Because this vector embedding, this vector space, and all these embeddings in there, they actually carry a lot of contextual meaning from the training data. And that's why it sometimes that's why it sometimes seems like large language models actually understand what they're talking about and understand context and everything. But what actually just happened is that they had so much training data that these vectors carry so much meaning. Okay, now what we want to do in the use case today is I'm first going to show you a hallucination of a large language model, and then I'm going to show you how you can use retrieval augmented generation to prevent hallucinations for my use case. So here you see how I import the chat model from our generative AI Hub SDK. And this is my deployment ID. So just to verify, I'm going to show you the exact same ID we got from here. AI Launchpad, there are all my deployments here. And which model is this? A27, so it's the 3.5 turbo model. And now we send the query to our large language model. And these roles here are actually very important because you know how when you use ChatGPT, for example, the application, and you write something and then you like have a little chat, and then later on you refer to something that you said earlier. And it seems like ChatGPT remembers what you said. And it's not that the model actually remembers what you said. It's not like you start talking to GPT and then somewhere there's like this little model brain that's only for you and it remembers everything about you. That's not how it happens. But what actually happens is that every time that you send a new response, the chat history is also being sent to the model. And that's how GPT remembers what you talked about before, because it's being sent every time as information. And how that works is that you have the role, the system role, which is basically like an overall role where you can, like, for example, tell it to always respond as a pirate or whatever. And then you have the user role, and you also have the assistant role. And those roles you can use to send this like history, the chat history, because like the user is always what you, or I mean your user actually prompted the large language model with, and the assistant is what the model responded. That's why you have these roles in a lot of the APIs for large language models. Okay, but today we will just say, you are Stephen Hawking, and tell me what you think of time travel. Is it possible or not? Have you conducted any experiments? Please answer as short as possible. And here I'm just using the deployment URL. Yeah, that's already it. Let's just run this for now and see what happens. So the response is, time travel is theoretically possible according to the laws of physics, but currently there's no experimental evidence to support its existence. Now, the thing is, I do know that Stephen Hawking did have an experiment, or something that he called an experiment, and that was the Time Travelers Party. And the Time Travelers Party was basically a party that Stephen Hawking held in 2009. And he only sent out the invitations after the party has already happened. So he had a party, he decorated everything, and he invited people after the party has happened. So only people from the future could have attended his party. And since no one came, he concluded that time travel is not possible because otherwise people would have attended his party, right? Now, when you realize that a large language model is hallucinating a lot for your use case, what you want to do is ground the model. So you want to provide context information for the model to use before it responds. And how do you do that? You, for example, use a vector store, like the HANA vector store, where you store important context information. And what would be important context information in my use case now? Well, I need something where the time travelers party is described or where Stephen Hawking talked about it. So what I did was I went online and I searched for time travelers party Stephen Hawking, and I found this interview. And then I just copy-pasted the entire interview page, the entire website, like this. I left in all the advertisements and all kinds of things. I didn't format it at all. So it's just a lot of text, and there's one part where he talks about it. On this day in 2009, Stephen Hawking held an invitation-only party. You are invited to blah, blah, blah. I have experimental evidence that time travel is not possible, Hawking said of the event. So we want the large language model to use this information before it responds, so that it doesn't have hallucinations, so that it doesn't lie. And and what's also really good about grounding models or retrieval augmented generation is actually that, you know how in business use cases you actually do not want the model to have hallucinations. You know, if the model doesn't know something, you want the model to say, I don't know. And that's what one good thing that also comes out of retrieval augmented generation is that when you provide context information to the model, but the information is actually not very relevant, then the model will say, I don't know. Or it's going to form a response from the information that you gave it. But if there's not enough information in it, it's just going to say, I don't know, which is also really good, especially in business use cases, right? Okay, so how can we implement that? I also brought some code for that, obviously. So let's start at the top. We again use our Generative AI Hub SDK. And we import chat models and embedding models because we need that. And then what we do is we use LangChain. LangChain is an open source framework for, just to implement use cases with large language models. There are SDKs for Python and for JavaScript. I don't know if there are any more SDKs to be honest, but those are the ones that are also compatible with our SDKs. And the languages that are also compatible with ours. And it just supports you to have like a more standardized way of implementing large language model use cases. And the HANA vector store is also compatible with LangChain. Yeah. Okay, so what we need is the text splitter because we don't want to squeeze the entire interview into one vector because then a lot of the context information can be lost. But we want to like kind of chunk it into smaller chunks and then always store these smaller chunks. So we need a text splitter, a text loader, obviously, the HANA vector database. And then this is our HANA Python SDK. I also imported that with the pip install command. Yeah. Okay. Here I just connect to my HANA instance. Then I'm using the Embeddings deployment ID and the large language deployment ID. Both IDs I get from my AI Launchpad. And then here I create an instance of my chat model. And then here I load the time travelers text that I just showed you, just the copy-pasted thing of the website. And then I split the documents into chunks. Now here I'm using a chunk size of 500 and no overlap, but you can also make the chunk size bigger or smaller. And you can also choose overlap. But for my use case, it works fine to just do it like this. Overlap means that obviously the chunks overlap, right? Yes, and then what happens here is that you connect to your HANA database. And I create the embeddings table, embeddings Stephen Hawking, so as Hawking. And then what I do is first I delete everything in the table. And then I add my text documents. And then I also add, I turn my HANA vector store into a retriever because with retrieval augmented generation, you first retrieve information, right, that you then hand over to the large language model to respond. And then this is basically how this retrieval question answering use case is implemented with LangChain. So here you give your large language model that you want to use. And here you give the retriever with all the embeddings and documents in it. And then what you do is you send your query. So again, my query is, you're Stephen Hawking. Tell me what you think of time travel. Is it possible or not? Have you conducted any experiments? Answer with less than 100 words. And now let's run this already. And then I'm going to show you how it looks like in HANA. So here is my HANA. And here you can see that I select the vector text and the vector from the embeddings as Hawking table. And by turning it to nvarchar, you can actually see the vector, how it looks like, and not how it's stored in the database. That's why I did that. So here you see the text of the chunks. And here you see the embeddings of those texts with these like 1,536 positions and a lot of numbers. Yeah, so for my interview text, we have 13 chunks here. And this is probably the chunk that should be used to respond to my query. But yeah, so let's have a look. So here's my query, and here starts the result. I'm not Stephen Hawking, but based on his work and beliefs, he was open to the possibility of time travel. He didn't conduct experiments, but he arranged a party for time travelers, hoping that someone from the future would attend. His research in physics, particularly on black holes, quantum physics, blah, 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 that led him to believe that time travel might one day be possible. Yeah. However, he didn't provide a definite answer on whether it is possible or not. Okay, so, well, it's true, a time traveler's party is not the most scientific experiment, but at least now the model tells me that there was a time traveler's party where no one attended, and that led him to believe that time travel is not possible, but yeah, due to all his other research, he thinks one day it might be possible. So in this Tech Byte, you learned how you can use the Python SDK of Generative AI Hub and HANA Vector Store to implement a retrieval augmented generation use case, which is a technique to ground large language models. And if you're curious how you can do that using CAP, you should join our live stream on the 3rd of May. Me and my colleague Kevin will join DJ Adams in his live stream in our YouTube channel, SAP Developers, on Friday morning. And we will show you how you can do all this with a really fun use case using CAP.